Hello everyone again. Let's continue. Um, as I said in the email, I'm not quite sure what the second question asked for, so I will skip this part because I think there's no need for us to do the virtual lab to determine the maximum concentration. Uh, so I will go uh, to work on problem 3. Problem 3 is to use the virtual lab, design and perform an experiment to determine the concentration of unknown hydrogen chloride solution to 4 significant figures. Um, well, the, a better way is to say the exact concentration of hydrogen chloride is unknown, because we know its rough concentration is about 0.1 molar right here. And then in this case, we only know the exact concentration of KHP, and we don't know the exact concentration of sodium hydroxide and the exact solution of hydrogen chloride. If we use this offline version, and then we don't need to worry about the realistic mode for this problem. So the first thing we can do is to do the titration between KHP and sodium hydroxide as we discussed before, right? For the question 1, we know these two will react with each other in 1:1 ratio. Oh no, here, yes, here. So they react with each other in 1:1 ratio, right? KHP react with sodium hydroxide in 1:1 ratio. Then here we know the exact concentration of KHP, potassium salt, and then we can titrate to figure out the exact concentration of sodium hydroxide. After we figure out the concentration of sodium hydroxide, we can use another titration reaction to figure out the concentration of hydrogen chloride. Here, hydrogen chloride and sodium hydroxide also react with each other in 1:1 ratio. So there are 2 steps, right? First, to titrate sodium hydroxide using KHP to figure out the exact concentration of sodium hydroxide. The second is to titrate hydrogen chloride with sodium hydroxide to figure out the exact concentration of hydrogen chloride acid. The first thing we need to do is to titrate sodium hydroxide solution with KHP. But then here we find that sodium hydroxide solution is very high concentration compared to KHP, because sodium hydroxide solution is 1 molar, about 1 molar, while the KHP's concentration is 0.09900 molar. So it's more than 10 times concentrated. Then the first thing we need to do is to dilute sodium hydroxide solution. Here I will show you how to do the dilution. So this is 1 molar sodium hydroxide, and we click, and then from the top right we know the solution is about 200 milliliter solution, and is 1 molar sodium hydroxide. In our titration, we are going to use a 25 milliliter KHP solution, and then here then we can prepare 100 milliliter sodium hydroxide solution with the concentration being 0.1 molar, right? Not 1 molar, but 0.1 molar. That means we first can dilute the 1 molar sodium hydroxide into 0.1 molar sodium hydroxide. And then to do that, we need to get a volumetric flux that we usually use for dilution. Okay, and then we can use the 10 milliliter pipette. So 10 milliliter pipette. Then we can pipette how many? We can pipette 10.00 milliliter, because pipette is a very accurate instrument. And then we when we pipette out 10 milliliter solution, it's very accurate volume. So that's the reason we put here, we put 10.00 at the bottom. At the bottom window, you see, that's the volume we want to pipette, 10.00. Then we click withdraw function at the bottom right here. Then we get this 10 milliliter solution, and then we can pour into the 100 milliliter volumetric flask. So we also put 10.00. So, and we do pour. Oh, before I do pour, I need to remind you here. You see that the solution level just reached this line. You see there's a line here. This line tells the exact volume should be. So when the solution level reach this line, it means the solution is exact 10 milliliter, is 10.00 milliliter. Same thing for this flask. You see there's also a line. You see there's also a line. And then when the solution level reach here, it also tells us the volume is 100 milliliter. Okay, then we pour. We're going to pour. Okay, here we have 10 milliliter 1 molar sodium hydroxide solution in 100 milliliter volumetric flask, and then we need to add about 90 milliliter water. So that's the reason we click this one. We need to add 90 milliliter water about, okay, to make this solution 100 milliliter. And then to do so, in the real lab, we normally don't just use this tank to pour. We first pour water into a beaker. Here we pour for, let's see. Oh, here, yeah. So we need to transfer water from here, not here to here, because there's no water here. Okay, now we can add 100 milliliter. At the bottom window, we put 100 milliliter. Here I'm circling. So we cannot put 100.00 because we cannot reach that accuracy. So we input 100 milliliter at the bottom window, and then we pour. So now we have 100 milliliter solution here, and then we need to transfer about 90 milliliter to make the solution exact 100 milliliter. Then we first can we need to pour about 90, but we cannot, when we do pouring, we cannot input 90 here, right? We cannot put in 90 here because pouring from beaker cannot reach that level of accuracy. If we set up 90, it's very likely that we can overshoot, and this system will not allow us to do so. And even when I try 85 milliliter. So you see, even I try to pour 85 milliliter solution, I get error message because the system knows I need to add 90. If I add 85, it is still possible for me to overshoot. So, and the system suggests that I should try 80. Then okay, I will try 80. So I try 80 milliliter. You see, at the bottom window, we try 80 milliliter, and then we do pour. Okay. So, and when we click this flask, and then we look at the right top, we see the volume is about 80 milliliter. It's not very accurate. You see, this is just a piece of information, but it's not very accurate. You see, it means about. It has this kind of sign, meaning the volume is about 80 milliliter. And later on, we need to add water using disposable pipette. So we use disposable pipette, and each time we can add 1.0. So that's the capacity of the disposable pipette, and then we need to add 1 milliliter by 1 milliliter. Then we first withdraw, and then we pour. You see, 1.0. You see, now the solution level is behind. It does not even reach here, right? Our goal is to make the solution level reach here. Then we add 1 milliliter each time. We add 1. So now we add pour 1. Okay. As you can see, the solution level still does not reach this level. and then we just keep adding. We can add 1.0. We withdraw 1 millimeter, and we pour 1 millimeter. Okay, so this part may be a little bit boring, but we have to do that so that we won't overshoot. Then we add 1.0. Then we withdraw, and then we do pour. So withdraw and then pour. Same volume. Pour and then withdraw and then pour. Withdraw and then pour. Withdraw and then pour. You see the solution level still has not reached here. Then we can just keep adding 1 millimeter. Withdraw, pour. Sorry. Oh, just now I click withdraw, so I need to put pour again. Okay. So withdraw. And then pour. You see the solution level still has not reached here. Then we need to keep adding. 1.0, withdraw, 1.0, pour, withdraw 1.0 millimeter. You see the accuracy for the accuracy we cannot put 1.00 because the pipette cannot reach that level. And then we do withdraw, and then we do pour. See the solution level still has not reached here. Then we just keep adding 1 millimeter. Pour. And 1.0. Withdraw. 1.0. Pour. 1.0. Withdraw. 1.0. Pour. 1.0. Withdraw. 1.0. Pour. Okay, now you see the solution reached that level. Then we need to be very careful, so we don't want to overshoot. And then we pour and we withdraw another 1.0 millimeter. Okay, withdraw. And then here we don't want to overshoot, so we can add slower. We can add 0.5 millimeter, and we see what happened. Pour. Okay, so 0.5 won't increase the level much. Then it's safe for us to add another 0.5. Okay, and then there's no solution left. Then I need to withdraw 1.0. Withdraw, and then it appears it's safe for me to add 0.5 safe again. So add 0.5. Withdraw. Okay, and I can add another 0.5. Oh, okay. Then we go to get 1.0 liter. Withdraw that much. But here now we don't want to add 0.5. We may need to add 0.2. Okay, 0.2. pour. Okay, you see the bottom of this water level is exactly above, maybe still need 0.1. Let's try. Okay, I get 1.0, withdraw, and then I can add 0.1. Let's see, 0.1 milliliter. So pour, you see, okay, then maybe pour another 0.1. Good. So when the bottom of this shape is just above the line, it means the volume of this solution reach exactly 100 milliliter. So just now we prepared a 0.1 molar sodium hydroxide solution, and now this bottom is not and we need to first rename it. And just now I do some trial experiment, and then I use some sodium hydroxide, 0.1 molar sodium hydroxide. That's the reason you see this flask is not full. And now we can do the titration. Okay, to do the titration, we need to pour. We need to use Erlenmeyer flask. So we use that much. We use this Erlenmeyer flask, and then we first transfer 25 milliliter. 25.00 milliliter solution, KHP solution. Okay, we withdraw. You see the bottom right, we can withdraw that much, and then we can pour into this Erlenmeyer flux 25.00. Okay, we pour, and to do the titration, we need indicator. Okay, so here's the indicator. Oh, we can directly pour, but we don't want to do that. Yeah, we need to use pipette. Okay, we use pipette to pipette out some solution. This is not allowed. You see the red arrow, the red sign means this is not allowed. Then what we can do, we first pour some solution to beaker. Okay, we pour 10 milliliter. Okay, 10 milliliter. Oh, we cannot reach that accuracy. We just put 10. Okay, we pour. Okay, and then we add some indicator. We withdraw some indicator solution, 0.02 milliliter. Withdraw that much, and then we can pour 0.02 pour. Okay, and then here when we click this bottle, we can see there's KHP there and there's indicator there. So here we rename it. Okay, 25 milliliter KHP and indicator. So, and then we can do the titration. To do titration, we need to fill the burette. Okay, 50 milliliter burette, and then we pour. Just now I use just now I did some trial experiment and I used 42 milliliter, and then we, even though we want to fill 50 milliliter burette, we cannot, when we do the transfer, we cannot input 50 milliliter because this pouring through beaker is not very accurate, and then it's very likely we'll overshoot if we input 50 milliliter here. If we input the transfer amount to be 50 milliliter, so the system will suggest we use. Okay, let's see how the system responds. So even though we try to pour 45, the system does not allow. The system suggests 40 milliliter. Okay, then we try 40 milliliter. So before I click pour, we can take a look. So here there's no solution, and the 50, the reading is at the bottom, is not at top. And then when we want to calculate the amount, we use the difference before and after adding solution. So the starting pouring level is 50 here, and then we can do some. We can do the pour. You see, the reading is what is nearly 22. Then we can do the calculation. So the initial reading is how much? Is 50, and then here the final reading is around 22. That means we add about 28 milliliter solution. 28, and then we can stop here, and we need to keep this volume, and we can do some rough calculation and find that 28 milliliter solution should be enough for the titration, right? Because at the equivalence point, the moles of KHP and the moles of sodium hydroxide should be the same. So the moles of KHP is 25 milliliter times what? The concentration 0.09. So 25 milliliter times 0.09. Then that is the millimoles of KHP. Millimoles of KHP. And the concentration of sodium hydroxide here is about 0.1, right? Then we divide 0.1. So that tells we need roughly 22.5 milliliter. And now, as we calculated just now, there is 28 milliliter solution, about 28 milliliter solution inside this burette. So it's enough. And then before we do the titration, we need to keep this initial reading in mind. So it's about 21.95. Here is 20.995. Okay, that's the initial reading we need to record. And then we can add now. Okay, then this is good enough. And now we can do the titration. So we know we need about 22.5, right? So it will be safe if we add 19 milliliter at the beginning. Okay, 19 milliliter. We do the pour. You see, the color does not change. Okay, the color does not change. And now we can start to do titration slower, and then we can add 0.2. We can add 0.2, or we can be more cautious. We can add 0.05, and we can just keep pouring. You see, I click. You see the right bottom. We click pour. Okay, and when I click pour, the solution level decrease. And what we need to pay attention to see when the color change. Okay, 0, and then we keep going. You see this, as I click pour, the solution level decrease. We need to pay attention when the color change. See, I just keep adding 0.02 milliliter each time, and then pay attention whether there's color change. You see, there's color change. Okay, now we reach the equivalence point, and then we record the reading is what? Is 43.9, and then 43.9. Right, 43.9 minus 43.9. So the difference is about 21.95 milliliters. So we add that much. So that's their final reading, 43.95. Then 21.95 is the volume of sodium hydroxide we use to finish the titration. So 21.95, and then we can do the calculation. You see, for the potassium, for the KHP, the volume is 25, the concentration is 0.09, right? Then for the sodium hydroxide, the volume is 21. Then we divide it by the volume of sodium hydroxide. Then that's the concentration of sodium hydroxide. after being diluted 10 times, and we need to record this to do what? To titrate hydrogen chloride acid. And then, so if you're not sure, here it's very obvious there's some color change. And then if we add another 0.05, you can see the color becomes even darker. You see that? And if we reach this point, that means we overshoot, and we don't want to do that. Now we reach the last step. Here, I mean, there's no need for me to finish, but there's something I need to tell you. So here we use some sodium hydroxide, right? And we use them out, and then there's not much sodium hydroxide there, and then we need to refill sodium hydroxide, and we need to prepare more sodium hydroxide solution. Maybe at the beginning we need to prepare we need to use a, let me see, a volumetric flux 250 milliliter. So we should prepare more. Okay, at the beginning maybe we should prepare more. So here we fill the sodium hydroxide solution here, and then we can do the titration. We put the, okay, here is the Erlenmeyer flask, and then this is 0.1 molar, HCl solution. And then we can, same thing, we can use the 25 milliliter solution. We can pipette 25 milliliter. And then we add, so 25.00 pour. Okay, here we have what? We have, I name it, we have 25 milliliter HCl solution, and the concentration is about 0.1. And now we know the concentration of this sodium hydroxide, right? And then same thing, we can add some indicator. So we cannot do that. We need to add some indicator. So yeah, we need to add some pipette. We use disposable pipette. Okay, disposable pipette. We add 0.02. Withdraw, and then pour. You see this solution, we have let me see. So we have HCl, we don't have KHP, we have HCl, and we have the indicator. Then after we fill the burette with more sodium hydroxide, then we can do the titration again.